I'm I welcome you all to Mathscriber. In this video, I'm going to discuss about some difference identities. Before we start, I must say if you are fond of learning advanced math stuff, please click like and subscribe. To get to know about my earlier classes, visit mathscriber.com. So here we go. Let's get started. Alright, first let's see how to derive some difference identities and later we'll see some practical math problems. Now let's consider this diagram. Now we consider this as capital A angle and this is capital B angle. So basically if you consider this complete angle, it will be A plus B angle. And now as you know, now these all are parallel lines and these will be vertical lines. And now if this is A, considering alternate angles of this Z letter, if this is A, this will be A. Okay, now if this is A, this will be A considering the alternate angles. And if this is A, since this angle is 90 degrees, this angle will be 90 minus A. And if this is 90 minus A, since this is 90, this angle will be A. Now let's consider cos A plus B. Now cos A plus B, which means this angle, will be adjacent side over hypotenuse, which is OL over OP. Now what is OL? We can write OL as OM minus LM. How did you write that? Now OL we can write OM length minus LM length, so we get OL length. Now we write these separately, so it is OM over OP minus LM over OP. Now we can write cos A plus B. Cos A plus B, OM over OP. I'm going to write something here, so just I'll keep some space, and minus LM. What is LM? LM we can write NQ because this is a rectangle, these are vertical lines and these are parallel lines, so they are perpendicular to each other. So we can write LM as NQ because these are equal. So instead of LM, I'll be writing NQ. Now this is NQ over OP. Now we are multiplying this OM over OP by OQ over OQ. We are not doing anything wrong because we are multiplying up and down both. So these will get cancelled. So still OM over OP is remaining. So now NQ over OP we are multiplying by PQ over PQ. So we swap these denominators, which means now we first write OQ, then we write OP. I just change these two, and minus NQ over PQ times PQ over OP. Now what is this OM over OQ? OM over OQ. OM is the adjacent side of this A, of this OQM triangle, and OQ will be the hypotenuse. So OM over OQ will be cos A. So instead of OM over OQ, I'll be writing cos A. Now what is OQ over OP? OQ over OP. OQ is the adjacent side of this B and OP is the hypotenuse of this OQP triangle. So OQ over OP will be cos B minus, now what is NQ over PQ? NQ over PQ. Now NQ is the opposite side of this A and PQ is the hypotenuse of this PNQ triangle. So NQ over PQ will be cos A. I'm sorry, it is sine A, because this is A and this is opposite side and this is hypotenuse, so it will be sine A, not cos A. So it is sine A, and PQ over OP, PQ over OP. So PQ will be the opposite side of B and OP will be the hypotenuse. So basically we are talking about the sine B. Sine B is opposite side over hypotenuse, so it is PQ over OP. So PQ over OP will be sine B. So we have derived our first sum difference trigonometric identity, which will be cos A plus B equals cos A cos B minus sin A sin B. Now let's consider, imagine, let B equals minus B. Now imagine this B was negative B. So we can write this cos A plus B as cos A minus B. Now cos A, now cos B, now when it is minus B, we can write cos minus B, which is when B is minus B, so this will be cos minus B. But considering the quadrant rule, what we discussed in the previous lesson, cos minus B is cos B. So we can write this as cos B. And now sin A, now I'll write this sin later. Now this is sin A. Now sin B, now B, when you substitute by minus B, so it will be sin minus B. So we know, considering the quadrant rule, sin minus B will be minus sin B. Now minus sin B, now here minus is there, so in the minus sin B, the minus sign will be multiplied by with this minus and it will be positive. So this will be plus and this will be sin B. So we have our second trigonometric identity sum difference, which is cos A minus B equals cos A cos B plus sin A sin B. Now we derived two trigonometric identities for cos A plus B and cos A minus B. Now let's consider about sin A plus B and sin A minus B. Now let's consider about sin A plus B and sin A minus B. Now if you consider sin A plus B, sin A plus B, considering this A plus B angle, we can write opposite side over hypotenuse, which is LP over OP. Now what is LP? LP we can write LN plus NP as an addition of two small lines. Now this ln plus np will be lp. So lp I am writing as ln plus np over op. Now that if we write separately, we can write ln over op plus np over op. Now I will be writing here. Now it is sin a plus b. We can write ln. Now ln we can write as mq. This ln length is equal to mq. So instead of ln, I will be writing mq. So it is mq over op plus np over op. Now I will be multiplying this thing by OQ over OQ, like similarly like the previous stuff. Now NP over OP I will be multiplying by PQ over PQ. Now what is MQ over OP? Now MQ over මේක කට් කරන්න පුළුවන් නේ. ඔය චුටි පොඩි කෑල්ල කවුලන්නේ නැහැ. Okay? හරිද? Okay. Now හරි. මෙතන අවුල. Now we swap these two sides. So just we can write this MQ over OQ times OQ over OP. What I did was I wrote these two changing the positions. Now OQ I wrote first, then OP then second, then plus NP over, I'm changing these two, so PQ times PQ over OP. Now what is MQ over OQ? Now MQ over OQ is sine A. Opposite side over hypotenuse. So MQ over OQ is sine A. Then what is OQ over OP? OQ over OP. It is now OQ is the adjacent side of B and OP is the hypotenuse. So OQ over OP is cos B. Now it is cos B plus NP over PQ. Now NP is this side and PQ is this side. So it is basically cos A. So adjacent side over hypotenuse. So it is cos A and then what is PQ over OP? PQ over OP. PQ over OP will be, now the opposite side is PQ of this capital B and OP is the hypotenuse. So PQ over OP will be sin B. So we have our third trigonometric identity for some difference. So it is sin A plus B equals sin A cos B plus cos A sin B. Now similarly what we did previously, so just we'll substitute B equals minus B. So when B is minus B, this will be sin A minus B and sin A cos minus B. Instead of B we are writing minus B. Cos minus B is itself again cos B, because cos minus theta is cos theta. And now when you substitute minus B here, now it is sin minus B. Now sin minus B means minus sin B, and that minus will be multiplied by this plus, so it will be minus cos A sin B. So we have our fourth sum difference trigonometric identity, which is sin A minus B equals sin A cos B plus cos A sin B. And now let's see about tan A plus B and tan A minus B. Now let's see about tan sum difference trigonometric identities. Now let's see tan A plus B. If you remember, we can write tan as sin over cos. So tan A plus B we can write as sin A plus B over cos A plus B. So tan A plus B we can write tan A plus B we can write. Now sin A plus B we proved previously, it is sin A cos B plus cos A sin B divided by cos A plus B we proved previously, it will be cos A cos B minus sin A sin B. Now we are dividing up and down both by cos A cos B. So when we are dividing, it will be, now we are dividing everything by cos A cos B. So it is sin A cos B, we divide by cos A cos B plus cos A sin B we divide by cos A cos B. Whole thing over. Now cos A cos B, we divide by cos A cos B. Plus sin A sin B, we divide by cos A cos B. What we basically did was just we multiplied the numerator and denominator by cos A cos B. So now we get this output. Now cos B will be cancelled off. So sin A over cos A is tan A. Now plus cos A will be cancelled off. So sin B over cos B will be tan B over. Now cos A cos B over cos A cos B, same thing over same thing, it will be 1 and minus, yeah, this is minus because this is minus now, so this is minus and minus. So then sin A over cos A is tan A, sin B over cos B is tan B. So we have our trigonometric identity for tan A plus B, which is tan A plus B equals tan A plus tan B over 1 minus tan A tan B. Like similarly what we did previous step, now by substituting B equals minus B, now okay, I'll write it. By substituting B equals minus B, so we can get, now instead of B we are substituting minus B, so it will be tan A minus B and equals tan A. Now when you are substituting B equals minus B, so this will be tan minus B. Tan minus B will be minus tan B considering the quadrant rule. So this is minus tan B over 1 tan A tan B. Instead of B, when you substitute minus B, this is tan minus B, which will be minus tan B, and minus to minus plus. So this is plus tan A tan B. So we proved the all sum difference trigonometric identities, and in the next video we'll discuss about some practical problems how to use these sum difference trigonometric identities. Till then, goodbye.